Okay, so for example 4, we want to find the angle B to the nearest degree for the truss shown in the figure. Do you guys know what a truss is? We had this conversation. What is it?
Something on the roof.
The truss is what holds its support for the roof.
It is. It's when you see a house that's being built and you just have the frame, it's the triangular structure at the top. And so there are a lot of, there are rules that say how steep a roof can be. Did you guys know that?
Mm-mm.
Yeah. You can only have roofs so steep, or else the roofers don't want to go up there. So some of the older houses were built before they had those restrictions, and the house next door to mine is super, super steep, and it was very scary to watch the men. It took them 3 people. They had to call 3 different people before they would come in and actually work on that roof because it was so steep.
Extra?
Probably, that would be my guess. So okay, so we just want to find angle B. And in this situation, we know the 3 sides. We know that it's 9 feet, 6 feet, and 11 feet. And we want to find that angle. So this is a side situation. So we're going to use law of cosines, right?
Yeah.
And the nice thing about law of cosines is there is no ambiguity. So it doesn't matter what angle you solve for. So we can find cosine of B by rearranging the formula. B squared equals A squared plus C squared minus 2AC cosine of capital B. So we'll go ahead and rearrange that. So we'll have B squared minus A squared minus C squared, and then we will have to divide it by negative 2AC, and that will equal cosine of capital B. Then we will just substitute into that formula and inverse cosine it, and we will have angle B. Cosine of B has to equal 6 squared minus 11 squared minus 9 squared, all divided by negative 2 times 11 times 9. Okay, so that came out to 0.83, 83, 83, 83, and so on. And we inverse cosine that, and we get second cosine of, we get 33.0301516 degrees. And it says don't use significant digits, it says go to the nearest degree. So we would round that to what? 33, yeah. If we use significant digits, we would only have 1 and we would round it to 30. But for this it says round to the nearest whole digit. So it looks like an angle of about 33 degrees. Make sense? Okay, that's the end of law of cosines. And I wanted to point something out to you guys in your book. Thank you. There is this chart, and it's a great chart. I don't remember what page it's on, but there's a chart that talks you through all 3 cases, well, all 4 cases, okay, for all 3 sections. So it's at the back of section 7.3, and it suggests how to solve them to avoid ambiguity as much as possible. So you most of you know your cases pretty well at this point, but you kind of want to study through those so that you don't miss anything. And because we did talk about with law of sines, if you have an option, it's better to solve for the smaller angle. With law of cosines, if you need all the angles, it's better to solve for the larger. So make sure that you're comfortable and familiar with this. So we'll pause here for a second just so you could read through it, but I don't think you necessarily need to write it all back down again. Okay, so make sure that you know all of your cases and what to do when. And for the last thing of section 7.3, we have another formula for finding area of a triangle. So remember back in section 7.1, we found that you can find the area of a triangle if you know 2 sides and the angle between them. How? By taking 1/2 of the side times another side times the sine of the angle in between, right? So that one was from 7.1. And guys, that will be on your memory quiz as well. All 3 versions of that. Remember how there are 3 versions depending on what side you know? Okay. So the area formulas will also be on your memory quiz. Okay, so if a triangle has side lengths of A, B, and C, It is called the semi-perimeter. If you take the perimeter and divide it by 2, you take half of the perimeter, okay? And they call that little s. And so if you know all 3 sides, you can find the area of the triangle by taking the square root of the semi-perimeter times the semi-perimeter minus one side times the semi-perimeter minus the second side times the semi-perimeter minus the third side. So there is a formula that you can use to find the area of a triangle if all you know are its side lengths.
Sixth grade.
Okay, so for this example, the distance as the crow flies from Los Angeles to New York is 2,451 miles. From New York to Montreal is 331 miles, and from Montreal to Los Angeles is 2,427 miles. We want to know the area of the triangular region between these cities. Why would we need to know that? Anybody know?
Flights.
The area? Why would we need to know the area? Any ideas? Manhunts? Like if you're gonna, you know, if you have to have a manhunt.
Finding a broken down plane.
Anybody? Finding a plane, yes.
In the middle of the ocean.
In the middle of the ocean, right.
10 miles down underwater.
So that would help us figure out how much area we need to scour, right? If we took 3 points there?
Yes.
Yes, of a triangular region. Okay. So for whatever reason, we want to know the area between those 3 cities. And in order to do that, we first need to find the semi-perimeter. The semi-perimeter is half of the perimeter, so it's half of those 3 distances added together. Okay, what is it? What's half of the perimeter, you guys?
Semi.
10,600. I don't know.
Guys, add them up and divide by 2.
2,604 miles, 1 shot.
2,604.5?
Yep.
Okay, great. So it's 2,604.5 miles. That's your semi-perimeter. Now you have to substitute into the area formula that says area will always equal the square root of the semi-perimeter times the semi-perimeter minus one side times the semi-perimeter minus another side times the semi-perimeter minus the third side. So it's a really long and tedious to type in, but it can be done in just one step. Make sure you take the square root, and then we are going to round it to 3 significant digits for our area. So here's what it looks like we got. We got 401,664.1109, and that's going to be square miles, you guys. And we will round that to 3 significant digits, so we'll round it to this guy right here. So that would really be approximately 402,000 square miles of area. And that is how you find the area of a triangle if all you know are the 3 sides.